Thank you very much, Paul. We are going to listen about the RobAgri platform with Jean-Michel Lebars and Roland Lenain. You have the floor. Good afternoon. I'm going to tell you about this subject. Jean-Michel Lebars. I have been working in electronics for about 20 years, and I'm going to tell you about a common initiative that was created a while ago and is called the RobAgri platform, an association which has just been created. And I will present this with Lenain from INTA. Some history about it. At the beginning, there was a demand from the ministry and from the General Directorate of the industry to make a report about future evolutions in the next 10 years in the sector of agri-equipment. There were two reports, in fact. In the Bourguignal report, the conclusions said that robotics in the next few years will become essential for equipments, and also the other conclusion was about big data. Following these reports, it was decided to start discussions about it. L'Axima, the Association of Agri-Equipment Companies in France, and IRTA gathered a few stakeholders and started discussing about this subject of robotics in France and how to start it. In 2017, after quite a few meetings, our discussions led us to the creation of an association to work very concretely in this field of robotics. On the top right, you can see the various stages in 2016, 2017, with the creation of the association that took place on the 20th of October 2017. The aim of this association is to help industrialists and startups develop robotics and put it on the market. This is not the objective in itself, to create robots and to commercialize them. The name of the association is RobAgri. No intention behind this word of RobAgri, just to mention it. So, the association was created on the 20th of October. You have the list of members there. 37 members joined the association on the 20th of October. There are various categories of members in our association. Category A is industrialists and startups. You have several down here. Players which are going to develop robots and put them on the market. In category B, we have suppliers, technology providers. In Toulouse, for example, we have Actia, which makes electronic systems to provide electronic solutions to the industry. In category C of members, we have public organizations and research institutions and laboratories, as well as associations, which can help develop projects and collaborate in their development. And the last group, the last category, concerns representatives of final users of the robots, cooperatives, for example. There is a federation, FNAMS, for example, an association which is highly interested in the use of robots. Membership is not closed. For the founding members have up to the 31st of December of this year to become members of the association. That's it. I'll give the floor now to Roland, who is going to tell you about the actual work of this association. Thank you very much. Good afternoon to you all. My name is Roland, and I'm going to tell you about our work, our structure, and the objective of the project. The aim of the game is to promote robotic solutions that are efficient, effective, and well adapted to human beings and to the farmers in particular. So we want to pool all the forces in the public and private sectors and the representatives of all farmers to reflect together upon the problems, the solutions that are possible, and the way we can certify the good operation of these machines, as well as the proposal of standardization. We have 8 major poles. The first one consists in a scientific monitoring of the state of the art, what is mature, what is not, where do we have to insist or do more work, and propose projects and consortium that will enable us to develop our ideas to serve the greatest number possible. From there on, we'll build a library of algorithm and software concerning design, safety, and so on, that will be used by all the members to develop robotic solutions. Then there will be simulations, and these solutions will be sold through common development platforms. We'll be able to compare the various algorithms and certify them eventually. If we have platforms for our tests, we will need infrastructures as well for experimental purposes, and we'll be able to propose procedures to certify these robots. And finally, we'll be able to propose it for standardization. So all agricultural robots will fulfill definite criteria in terms of safety and so on. And finally, we want to promote this type of solution and make sure they are known by the public at large and used everywhere. We have already started working on with four working groups that will continue working on the 20th and 21st of December on axes 1 and 2, technological monitoring and the development of projects, and on the building of certification and qualification infrastructures, as well as standardization. Concerning the first 2 aspects, we are going to meet on the 20th of December to talk about it. We have carried out an inquiry amongst members about the needs and solutions that exist today in the industry and in the research world. So we have there the most important needs in red and the solutions that are available today in green. These solutions are either immediately transferable or require more scientific studies and that need further development. So we now see what we need on the right-hand side, what are the most important needs for farmers, what do people expect from robotics for agriculture to be more environmental friendly, and also what are the general algorithms, what are the solutions that exist, what is the state of the art in France, in Europe, in the world. And then we say, right, this solution or that solution is mature, or that other one needs further tests and it has to be qualified or certified, or it needs more research. So we identified quite a few projects for the short term, anything to do with internal location, indoor location. In agriculture, there are many different conditions, lighting, and so on, a bit like on the road. We need pavements, we need ground marking, we need signage, and so on. In the middle term, these are only a few examples I'm giving you, so that we can reflect together upon what has got to be developed. So for the middle term projects, we have harsh dynamics control in varying environment, and finally in the long term, how to guarantee the crossability for a robot using low-cost sensors. That's what we're going to talk about on the 20th of December. On the 21st of December, we're going to talk about means and how to give ourselves all the means to qualify these robots. What infrastructure do we need to be able to say, well, that robot has been tested properly, it can be put on the market, it will be safe everywhere. These are a few elements of our reflection, because there's 40 of us in the association, and put together we have sufficient knowledge to take stock of the situation. So we invite you to become a member of this association, to come to us with your need, with your vision of agriculture and agricultural robotics for today, for tomorrow, so that we can pool all our knowledge, and so that we can define together tomorrow's agriculture. Thank you for your attention.
Allô, allô? Oui, ça marche. Donc, merci à vous deux.
Thank you to you both. I'll give the floor now to Coralie Bos from Groupama.
Bonjour à tous, je me présente, Coralie Bos.
Good afternoon, my name is Coralie Bos. I work in Groupama. I am in charge of insurance for tractors and agricultural equipment. So I'll tell you about the insurance for agricultural robots as it stands today. Agricultural robots have been around for about 15 years in farms, and we insure them in Groupama. We consider that they are goods belonging to the farm, and they are insured with a multi-risk contract. The latest novelty is that tractors go beyond the doors of the farms and go into the fields, and therefore they move around autonomously, and they can be on a road with other traffic. So the question that we ask today, as you have a whole range of robots at your disposal, is if you decide to go back home with a robot, do you have to insure it before you use it? Let us suppose that your robot tomorrow, when you use it in a field, encounters a non-identified or unidentified obstacle, let us suppose that you are injured by the robot, or let us imagine that the robot creates a traffic accident. Are you covered by any insurance? I propose that we look together at the regulation, at what the regulation proposes today, because the regulation is not very clear on the definition of robots today, and the fact that they are considered as motor vehicles. So Groupama, anticipating this regulation and the users' needs, and also to help our technological partners develop on the market, Groupama proposes an insurance that covers agricultural robots just like tractors and other agricultural tools. We have 3 types of guarantees: the civil liability, like in a car, when you cause a damage to a third person. The second guarantee is bodily damage for the driver. Now, it hasn't got a proper name because we have robots that do not need somebody driving them, but it can be very useful in terms of the damages to yourself when you activate the robot, or when you handle it or do the maintenance. Third category of guarantee is the damage. Damage covering theft, fire, electronic damage, and all types of damage that can be found in tractors and other agricultural tools. So today we propose a first coverage for your robots, but we are fully aware that we must develop further clauses and further coverage, because there is a big difference between the traditional tractors that we see around today and the robots that start appearing. Not in terms of final objective, because they do similar work like weeding, for example, or fruit picking, but the functions are very different. The robot will function autonomously. It will be 100%, up to 100% autonomous without the presence of a man. Hence, what about the guarantee against theft? The robot can be stolen, except if we can have geolocation sensors, for example. We have other categories of risks, like, for example, the cyber risk. Imagine that your robot is pirated, or your fleet of robots is pirated. We must therefore protect also all personal data that will flow around through via connected objects. So we have a lot to build together, and we want to be present. We want to accompany the builders, the manufacturers of these new technologies, by sharing risks, because if a robot can carry sensors, it can also bring information to us concerning risks. We'll be able to know the situations better, understand what has happened in an accident, and we can use them to assess damages. Groupama is highly interested in drones. It has developed its own drones for crop and harvest insurance, to assess what's happened when there is damage. All this to tell you that Groupama want to be a driver in this innovation, and we do want to contribute to the elaboration of new robots, because robots are intelligent, and their intelligence has to be used. Human beings make errors, repeat their errors, but robots can correct all this, can improve the work of a farm, and be useful in the future. Thank you very much for your attention. Thank you very much. I will start with a question after giving you the floor. In other countries, is there a well-established insurance system and a regulation around robots.
Les robots de façon très
Well,
large.
concerning robots in the wide sense of the term, and there is a regulation on cars in the United States. Autonomous vehicles circulate in real situation. They are being tested, but they move around in real situation. The regulation is not fully operational there, but they are starting to view the issue in this way. They separate the liability of the driver and they make a difference between the vehicle on one hand and the autonomous system on the other hand. It is true that, at least in France, as an insurance company, it is important to categorize robots and to standardize the insurance coverage.
Au niveau de la normalisation,
concerning standardization,
Roland Lenain,
and my question is for Roland Lenain, you're working in France on this issue of standardization. Does this exist in other countries? Have they progressed in this field in other countries? Well, I know that there is an ISO standard which is being drafted on highly automated systems in agriculture. And this responds partially to this. It's only the beginning. It's only the beginning, and in our association, we try to interpret what exists and to define new standards. Paul, do you have any? Can you say anything about all these aspects of regulation and standardization in Norway or in Great Britain?
Well, there's definitely a need for standardization. I think that's one of the main challenges that are before us. I don't see any sort of technical challenges in getting robots out there. I think they're more in the legal terms. What's legal? What can you do? And not for the robots itself, but the fact that they're autonomous and there's no one out there. So I think there's definitely a need to work on that. So that's one of the sort of what I'm maybe hoping could come out of this kind of meetings is to get people from different areas working in agricultural robotics together and discuss this, so that we all at least the ones of us that make robots, we need to agree on what we want these standards to look like, and then we can go to the governmental organizations and so on and try to affect the way that this is actually
harmoniser en fait.
Yes.
D'accord. Et alors autre question, Paul.
Another question, Paul. You already have a lot of experience in robotics. Have you measured, in terms of time or in terms of economics, the productivity or the performance gains between a traditional system and the use of robots on different productions?
Well,
do you have a figure to put on this?
We haven't actually measured it, the difference, but the comments that we always get is that, okay, well, can these tiny small robots, can they compare to huge tractors, right? And I really believe they can. First of all, because they're so small, they're so cheap, they're going to be very, very, very cheap. And farmers are going to have fleets of these robots out there. And I think the scalability of having small machines is just incredible. So I think we need to use this scalability, and that will also make these robots more efficient when they work in fleets.
Mais il y a quelque chose que je comprends pas bien là-dessus.
But there is something which I don't understand very well. We cannot always replace huge machines with small robots. Surely there are some functions that are different. Is it as easy as that to replace big machines by small robots?
I definitely hope so. I don't think it will definitely take some time before we see small robots operating the huge fields in the United States. Maybe that will never happen. It should happen. Hopefully it will happen because, you know, compaction, environment, and all those things. But robots will not be seen in those fields for some time yet. So the first areas where we'll see robots is where we have less biomass and, you know, high quality, high value crops.
Je pense que ça viendra, mais ça mettra plus de temps.
I think it will come, yeah. It will come, but it will take time. Especially for large surface areas. We're talking about small herds, but it is quite complicated to manage because there'll be fleets, entire fleets. It's important to start with sectors that can be robotized more easily. Are there questions from the floor? Good afternoon, André Gavalan, INRA. My question is for Coralie. You said that you are using drones to assess damage on crops, for example, or harvest, but as an insurance company, Groupama, do you propose formula to insure drones for your clients in agriculture, research and development? Indeed, we have a solution to insure drones today in Groupama. Yeah, we do have an insurance coverage. To go back to what Paul was saying earlier on, we have worked in various working groups to develop drone solutions and to contribute to the evolution of regulation on this. We're talking about aerial civil liability, and we actually won very quickly on this subject. So we must do some similar work for terrestrial vehicles, but it is a good example to follow, yeah, for our future work. Thank you.
One question at the front of the audience over there, please. Another one at the back. You have the floor, so you can, well, for the association first.
Y adhérer. Et ensuite, qu'est-ce que ça apporte personnellement à
subscribe. Is it good for the farmer who's interested in robots? Could you introduce yourself first? Well, my name is Jean Rochefort, and I'm the father of a farmer who's doing organic farming, market crops. So the association, you can certainly subscribe. So what we are envisaging are companies or research centers or establishments like cooperatives, and which will open are considering not so much open to the farmers. We are considering the development of robots. I don't know whether I've understood your question clearly. Yes. Something else? Yes, another question?
Question devant.
At the front, yeah.
Ici, devant.
At the front. Somebody wants to ask a question. Yeah, you have the mic.
Great presentation. So the first equipment that was made for farming was a stick to plant seed, and the big revolution was the moldboard plow, and then a plow being drawn by oxen. So this is the next revolution, but those were, and the tractor was invented to do this really heavy work of ground preparation. Is there any thought about how robots will come into play in terms of preparing fields, ground preparation for planting?
Yes, I can say a little bit about that. Yes, we have thought a lot about that, and I think there's a huge potential in preparation of the fields. I think you need less preparation. That's the whole idea. You have smaller machines. You don't need to, as Simon Blackmore described, sort of solve the problems that you create when you prepare the field. And also when it comes to seeding, I believe a lot in precision seeding, variable seeding rates depending on the area. And I think the future seeding systems will be extremely precise. I don't think you will do a lot of work in the soil when you do the seeding. I think you'll be a lot more precise. And I think you will reduce the amount of energy needed to do those kind of operations. So I think you'll adapt the seeding systems to, well, basically you'll make an optimal seeder. So you don't, today we seed in rows because that's what we're able to do mechanically. When we use robots, we can just change the whole way we do those operations and seed in different patterns. And those seeding mechanisms will require a lot less energy than what we do today.
Très bien.
Thank you for all the speakers. That's it.